about
and telecom initiatives. Presently working as an executive director at Standard Chartered Bank, responsible for information security strategy and driving technology-related transformation program. Anand has expertise across multi-domains of information security, including data security, penetration, application testing, PKI, encryption, GRC, cloud and platform security, exploit research, and managed security services. We welcome Mr. Anand Kanuri to deliver the session on practical cryptography in the enterprise and cloud. Over to you, Mr. Anand.
Thanks, Vijaya. Let me know if I'm audible, and I'm once my screen is visible to you, right?
You can start sharing. You are audible.
Let me know once my screen is up.
Yes, it's up.
All right. Thank you. Thank you all so much for having me here. I'll take this opportunity to talk about a subject which is potentially very hard on a difficult piece of puzzle for most enterprises, and essentially I'll be talking about the journey that we went in at Standard Chartered and some of the learnings that we've had, and with the aim of giving out points on how other enterprises might benefit from this journey, right? The agenda at a high level would be that I'll set the context in terms of the importance of cryptography and the challenges that most enterprises face. Then I'll read you through our enterprise journey, and I think that'll be relevant to most enterprises who are grappling with finding the right solutions for cryptography. I'll talk about a little bit of on-prem experience as well as the cloud. Then we'll look at dealing with the cloud challenges, how are secure enterprises reacting and adopting cloud and encryption around in the cloud space, and then finally leave you with a set of recommendations. Right. Again, from a context perspective, I think all of you are security professionals, and most of you would have the context on why encryption is important. But just to set the stage again, the data is multiplying day by day, right? You have statistics which say that you have 2 quintillion bytes of data that is generated. I don't even know how many zeros that actually is. 90% of the world's data was generated in the last 2 years. Data analytics have become almost, and machine learning have almost become mandatory tools in an enterprise business. Enterprises are earning plenty of dollars based on data. Right. If you take that at one hand, then you have on the other hand, and especially from the sector that I belong, which is banking, it's a highly regulated enterprise, and that's the trend that most enterprises are moving towards. Most verticals are moving towards multiple regulations requiring, and most of them call for strong encryption, stroke tokenization at multiple levels. Right. Then, as the previous speaker brought out, you have multiple privacy and data localization requirements, which are driving the requirement of encryption. And if you look at it, and we did an exercise of trying to map out the current regulations, and we could sort of list out more than 110 to 115 different requirements of encryption, key management, call out in multiple enterprises, right? And the common theme across, if you take it across, it would be that it would be protection of the PAN data and payment data in with banks, then protection of PII for primarily driven by the regulatory, by the privacy requirements that we're seeing. If you take the other end of the scale, data breaches are continuing to exponentially increase, and we've don't want to go into the statistics. Most of you would be knowing of the major data breaches that keep hitting our headlines almost every second day. Some of them would be the Capital One breach, the records of the AMCA, and the etc. On the other end of the landscape, you have the GDPR, and from a potential threat, we are seeing proof that it's actually a threat which is absolutely incumbent on enterprises. You would be aware that British Airlines has been fined more than $220 million, Marriott about $120 million. You have data breaches from Equifax, which cost them a whole ton of money, and so if it's a complex jigsaw puzzle, and ultimately it all boils down to risk. Non-compliance of regulatory would result in fines. That's a given. Loss of reputation. That's also a given. Privacy requirements are now real. Besides protecting customers, they are a real threat for enterprises. From an enterprise perspective, they cost them dollars, right? Loss of customer trust and revenue is a consequence of that, right? And the major reason for this, for if you're unable to take a risk-based approach, would be caught in a cocoon as to how do you adopt all the shiny new technologies that are coming up in the market, and at the same time maintain your security. So with this context, right, and if you look at cryptography, right, and everybody agrees that it's a great tool. It's probably the last bastion of defense that enterprises have, because when everything else breaks, cryptography is your savior, because your data itself is encrypted and protected. If it's such a valuable tool, why is the crypto landscape so broken in enterprises, right? And if you look at the potential reasons for that, right? Firstly, encryption is not an easy problem to solve. It is a hard problem, hard problem. And as I lead you through some of the typical challenges, you would understand why it is hard. The second point is encryption is intrusive. Unlike a bolt-on solution, if you have a firewall, it's the end user is used to that control. He doesn't necessarily feel inhibited by that control, whereas encryption is intrusive. From a developer's perspective, it's a pain to implement, and therefore it's a hard problem. The third point is that it impacts connected systems. You can't take encryption in isolation in most cases. You just encrypt data on one system, but you have upstream systems which, from where data is flowing in, you have downstream systems which are consuming this data, and therefore it's you can't view encryption in or from a single application. You need to understand the entire ecosystem. And the risk buy down is not very obvious. Well, the arguments would be that what can encryption do that access control cannot, right? And while I've called out on the regulations, that there are close to about 110 regulations which call out encryption, key management, tokenization, etc. How to implement and what exactly, how do you interpret that? There's a lot of scope of ambiguity, and so it often ends up as a checkbox control, and that's another reason for its low adoption in enterprises. Then it can obviously break functionality for all the reasons that we've said, and then it's a costly exercise to adopt. Right. So before we actually get into the typical enterprise journey of how encryption can do, I'll just do a little bit of a context setting in terms of most of you are professionals, we would understand, but still, you have these terminologies: encryption, tokenization, masking, etc. Right, and that's called out at the bottom left-hand corner of this slide. That encryption takes a piece of data, converts it into an unintelligible binary blob using a key, right? And that's obviously has many positives, but it's also got a flip side to it, that from an application perspective, it could break functionality, right? So that's the reason you have concepts like tokenization, which is essentially converts the data into something which looks very similar to the original data, but it's obviously totally different and randomly generated from this thing. And then you have the masking, which is primarily a visualization technology, wherein you actually at the storage level, you have the original data as it is. It's only by that when it is displayed, you mask out certain elements of the data, right? And at a high level, encryption is great for unstructured data, for transactional data in some cases, right? And you would so typically use encryption for encrypting files, folders, etc., etc. And tokenization would primarily be falling in, would be looking at the use case for it would be in the structured data elements, where you have individual data elements, the PAN data, PI data, say in databases, right? So at a high level, this is what the difference between the encryption and tokenization is. The other thing that I want to sort of set out right at the very beginning is that there are encryptions and there are encryption, right? You could, if you take, it's used as a very broad brushed term in terms of what encryption is, right? But you could encrypt data at a storage level, you could encrypt it at a file system level, you could encrypt it at a database level, and you have and you could encrypt it at an application level. The risk versus benefit is typically, as a rule of thumb, there it's the what layer of protection, what protection that each layer offers is on the slide. But typically, as a rule of thumb, the higher up in the layer that you go, better is the protection that is offered. But it's also so much harder to implement. Therefore, if I'm doing a encryption at a storage level, all I would need to do is probably choose a storage element which has got inbuilt encryption at the most, plug on a key management system to hook on with that, and you're done. There's no impact from an application perspective, from a user perspective, or for anybody who's consuming the data, because that gets transparent. But from a protection perspective, what does it offer? It offers you protection only against, say, a physical theft of the data, right? At the other end of the scale, if you have encryption at an application level, it offers you obviously the maximum amount of protection, because it protects you from all users of your operating system users, your database system users, and certain class of application users, right? But the implementation of such a scheme is so much more complex, because you would probably need application level code changes to do that, and therefore it's always, when you're talking about encryption, it's always a trade-off between the complexity and the risk benefit that and the buy down that it offers, right? So the best way to look at encryption and articulate it to stakeholders within the enterprise would be to, encryption is never a substitute for trust. It should always be viewed as a complement to, rather than a replacement for, access management controls. So a combination of strong access management controls with encryption gives you a control which is extremely effective, right? So with that context, I will step into what what are the typical enterprise challenges in adopting encryption at scale, right? When I'm talking about encryption, we're not talking about toy encryption, which is probably done on desktops and zip files and folders which are encrypted. How do you implement enterprise at scale? How do you build a business case for that? What is your articulation to the larger community, and how do you start off, right? Again, the drivers for encryption and modernizing data security, which under which encryption would fall, would typically that most a competitive organization are on a digital transformation journey, and this is almost been beaten down to death, but it is a fact that digitization is a very important component in any modern enterprise today, right? Then a consequence of that is that the data, as we saw earlier, is a very valuable asset and a risk, and baked in, and the idea of any enterprise is that it needs to be, the security needs to be baked in, and it is not to be an add-on, right? And unless we demonstrate that there is a total cost of ownership because of the control that is being implemented, we are not going to be able to get the business buy-in to implement a control that is going that's effective, and it's got far-reaching consequences. The last point about why this is going to become important as we move ahead, it's just a matter of time that every enterprise moves to the cloud. These sheer flexibility and the apparent benefits in terms of the the expenditure coming down very few enterprises will be able to resist moving from the cloud. So with this cloud journey, encryption, as we'll discuss a little later in the talk, will become that much more important, right? Now, most enterprises would be find themselves in this state, right? You would have encryption, and I said that's primarily because of the 110 odd regulatory requirements that we had talked about earlier, right? But that would be just enough to meet a regulatory requirement, a check in the box kind of for this thing. So typical state of the enterprise would be that you will be having ad hoc bits and pieces of encryption, all of them operating in silos and what we call as crypto islands, without any interoperable capabilities. So effectively, while you might have a control which could make you look good, it's not enterprise scale, and therefore it doesn't scale well at all. And unless you have a framework for implementing cryptography at an enterprise level, you would end up with a large number of homegrown solutions which developers have come up with as for meeting a specific requirements. That this again would result in crypto islands with no interoperability upstream, downstream with any other system, right? And the last piece for it is by having these siloed islands, you would not have governance or visibility into the entire encryption process. So these would be most, and we were at the same kind of a situation when we started off with, but this I in my experience of looking at enterprises for both from managed security service perspective as well as somebody who's implemented them, most of the enterprises would be grappling with similar kinds of challenges in terms of encryption. So what a good way to do it is look at breaking up the problem into smaller buckets. While you think big, look at trying to break the entire journey into smaller pieces of smaller projects, which you could start off with a consultancy project to look at what your current state of enterprise is, then look at establishing the controls and the governance required for implementing encryption, tokenization, key management on the premise. Then look at how that scales up to the cloud, and then multi-cloud, right? So that would be a good way to break up a complex problem and try to look at it while looking at a larger vision, trying to understand where exactly you are in the journey of meeting your end state would be a good starting point to begin your journey, right? So that's what we did from a Standard Chartered perspective, and what we tried to build was to build something which is called cryptography as a service. That is, it's a combination of technologies. Obviously, technology is very important, but more importantly, patterns which can be repeatable patterns which can be consumed by applications, infrastructure components, security products in a consistent and a scalable manner, right? As long as it is, it's not consistent and cannot scale, we're not solving the real problems, right? So that's what we started doing. And when we looked at what the requirements for such a service would be, right? There were some golden rules that we set for ourselves. That is, set out to build for the enterprise. Do not look at point solutions. Build something which will scale out, and it's enterprise, and it can sustain itself for the next 10 years or so. Use standards wherever which is possible, right? The encryption the marketplace is so confused and everybody wanting to grab the sale in their eagerness to grab keep the customers logged in. They've come up with a whole set of proprietary products which don't interact or interoperate. So look at standards like key management interoperability protocol, PKCS 11, etc., so that your product choice meets at least 60-70% of is standards compliant. There will always be elements, for example, tokenization doesn't have a standard which become proprietary. You would probably need to look at a vendor who does the best job there, right? And then think from a developer's perspective. This is not a platform driven thing. It's encryption ultimately would be a developer driven success story. Unless you have friendly APIs and it's developer friendly wrappers that are available, you would be falling short of your goals, right? Again, try to map as many regulatory requirements to the product that are being chosen, and with this, right, and look at solving at scale. The key problems that you'll be looking at, most enterprises would be key management, HSMs, a whole ton of HSMs which would have proliferated in the enterprise. How do you consolidate and abstract out the complexity of the HSMs, tokenization, and encryption? So these would be the 4 pillars on which any solid enterprise cryptographic service would be stood upon, right? And once you do that, once you have that vision in place, and obviously you will run through RFPs, etc., whatever, depending on the state of the enterprise that you find yourself in. The most important success factor for you is to alignment of the stakeholders, getting the stakeholder buy-in. And who would be your stakeholders? Obviously your business itself, right? Most businesses would be supportive of this cost, because for them it's a reduced risk till the time you look at the cost for implementation, right? So that's an articulation that needs to be very, very carefully spelled out. Technology services, obviously you will have platforms where your databases, your Windows and Linux servers, so the files, file shares, etc. So those are all these folks are going to be very important stakeholders. Obviously, the risk stakeholders are also your risk teams in the enterprise would be very, very keen stakeholders as well, right? So look at who your stakeholder are, articulate your journey and your vision very, very clearly, standardize your migration patterns at least a high level, make the migration easy conceptually when you, even before you start setting up the service, right? This is how your patterns are going to look like, right? Sell it that it is going to fix your audit, stress test outcomes, etc., and the risk buy down that is going to come in with this thing. Emphasize that cryptography is for the long term, and it's going to be a long-term service that you're looking at. It's not short-term gains, right? And hold a series of workshops. Unless, at least from our journey, we've conducted at least about 40 odd workshops with multiple stakeholders over a period of 1 year, articulating the statement, after understanding their use cases, and choosing products and solutions which meet their listing, right? And then again, also always remember that it's not going to be one day we switch on everything and everything is going to be encrypted. It is a risk journey. It's, as I mentioned, it's a complex deployment. Therefore, you need a prioritized way of approaching it. It's a long-term journey, which is going to be at least 5 years to even meet 50% of the enterprise requirements. So you would always need to prioritize what is important for and start engaging with those solution architects and the business teams to make sure that you will be able to onboard these applications when your service is ready, right? And once we did that, right, and the way we approach that, once we did this thing, once we prioritize, then you start looking at the on-prem journey. Then we'll start looking at what is it that we could start solving on premise. The typical challenges that you would feel be on premise would be that you would need to look at how it is affecting your storage requirements, your backup requirements, so on and so forth. How is the key management, that keys which are generated on one end of the application hierarchy reach the others? These are on-premise problems that we will need to articulate and solve, right? Once we did this, we built the service, did this thing, then we have a steady pipeline of applications which you can adopt and also start articulating the risk buy down that it is bringing, right? And the challenge with most enterprises is that you look at this from an enterprise from an on-prem model, and then you start blink and you say that 50% of your enterprise is planning to go to the cloud, right? And this is true for most enterprises that I'd articulated, and it's estimated that almost 75% of the workload is going of most enterprise would be or either public or private cloud by 2025 as per estimates, right? So digital transformation and cloud go hand in hand, and the cloud journey is almost an inevitable journey that we need to prepare for, right? So once you solve the enterprise on-prem problem, what would the typical challenges in a public cloud be, of not just from an encryption perspective, but overall from a overall security articulation and the risk buy down perspective, right? The first thing that you need to realize is that on-prem model doesn't scale in the cloud, right? You say it's not just lift and shift, especially in terms of encryption, that you just take from what is on-prem and just move it to the cloud. It just doesn't work like that. You should always remember that data is always the customer's responsibility, irrespective. In the shared security model, data is always the customer's responsibility. So your most critical data would still need to be protected by methodologies which are outside the cloud service providers' native controls. Granularity provided by the cloud native controls, it's a balance. I won't say that cloud service provider do not provide enough granularity and control in the encryption space. They have some things which are very easy to implement, already baked into their product offerings. But there is always going to be a set of data which you would want totally under your own control. Therefore, you would need to factor for it and look at it. Protecting sensitive data totally under the control of the enterprise is something that's an inevitable requirement that is going to become, unless you are prepared to do that and invest in patterns and solutions for around that. The businesses will go and implement, and then you start looking at bolting on security or encryption at a much later stage, right? And most cloud service providers do not offer tokenization. Therefore, for your PII requirements, you would need to figure out as to how tokenization would be implemented in the cloud. And along with that, a very important component would be your secrets management solutions as to how ultimately you would protect your keys, your passphrases, etc. in the cloud. This is something that that needs to be factored for. Now, once you look at from an on-prem to the cloud, and as I mentioned, it's not a simple lift and shift strategy that you go pull out what you have in the enterprise and then plug it into the cloud. The fundamental challenge of deploying anything that or an on-prem solution to the cloud is just doesn't scale. And most, in all probability, the cloud journey the beginning of a cloud journey for an enterprise would largely be to be driven by the infrastructure or the platform folks, and then followed by the business, right? You will get your shiny EC2s and whatever it is as your first, and then start looking at security, or then even the business applications, right? So if you try to bolt on-prem models into this thing, it just doesn't scale. For example, if you have an agent which is required to provide you encryption capability on a server, just trying to move that same agent into the cloud is just not going to work. You would have challenges in terms of auto scaling. How does the agent phone back home? How does it authenticate? How do you get certificates? So therefore, you need there are pattern changes that you need to look for. Automated provisioning of infrastructure. Again, unfortunately, on-prem solutions don't scale, because especially in this area of encryption, how do you automate when you have infrastructure as a code? How do you go and move that, right? Manual intervention, as I mentioned, is not possible, because you when you're doing infrastructure as a code, there you will not have an opportunity to interrupt the flow, add certificates, enter passphases, etc., right? And on top of that, you have all these short-lived containers which just live for short periods of time and automatically scaling. So unless you have containerized versions which equally are scalable, you are going to be having challenges in moving a solution to the cloud. So this is something that you need to do it for, and in many cases you probably need to look at custom solutions which would be required, right? This is one this thing, and for the way we've solved it is we've built containers in the cloud. We've integrated with the infrastructure as a code through automated key management practices. So these are some of the nuances that we would need to be aware of when you're trying to actually move encryption to the cloud, right? And that requires investment, that requires project fund, and that requires funding. That's something that you would need to factor for, right? The other thing that is very important in this journey is that the hiring mindset needs to change. Most security practitioners have on-prem experience. Most of them would be very proficient on tools, very proficient on even correlation and the things. But when you're doing it into this cloud, container, DevOps life cycles, right, you would need a development mindset. So how do you get your team balance right in terms of having practitioners, perhaps even hire developers or DevOps folks who have security experience, who can be trained on security for meeting with this thing. So unless you have a right mix of the bit of the security folks and you have people with developer oriented mindset in the team, it's again going to be a challenge, because the solution architects, the application and business owners always are always going to shoot the security folks down, throwing some jargon onto this thing. So unless you have people who understand that language, understand the semantics of it and the complexities of it, it's going to be a difficult journey. While you might have the APIs, the frameworks, etc., to do this thing, right? And finally, again, encryption and key management in the cloud. This is a very often debated topic, and most enterprises don't get it right. Who holds the key and who owns it, right? And people talk about bring your own key, and without understanding what exactly is the risk buy down you're getting out of the bring your own key. What are you truly controlling the key? It's primarily these are some of the nuances that you would need to understand. If you look at how BYOkey of most cloud service providers is designed, it primarily provides you a capability and reporting. Maximum you can do is generate a key on-prem and import it into the cloud, and have some visibility on the capability and reporting. The actual encryption keys and data encryption keys are still maintained and controlled by the cloud service provider, right? The articulation for that would be that you would need automated reporting and governance across multi-clouds, right? Encryption outside the control of the CSP, it's only inevitable at some point of time you would require. So they're judiciously, we need to use what is available natively and what you would want to introduce from your this thing, right? API driven encryption, again, as I mentioned earlier, without APIs, nothing is going to work in the cloud. So therefore, you would need capability in this thing. Form factors or VM containers, again, HSMs, mostly for regulatory requirements. At some point of time, you would require HSMs in the cloud. So therefore, what the options are, what are the cloud CSP's native HSMs that need to be understood and solved, right? Interoperability within on-prem and cloud service providers. So how do you factor for the interoperability capabilities? That how do you extend existing tools into the cloud so that they don't and that's where having standards that I mentioned about really helps, right? And your typical requirement would be that you encrypt on-prem, decrypted on the cloud, and vice versa. So unless you have interoperable solutions, you're going to be having challenge there. And once you solve the single cloud problem, you still then end up into multi-cloud challenges. And how, when you talk about multi-clouds, you have say AWS, Azure, Google Cloud, etc. Data generated in one cloud, it flows into the second cloud. Native encryption fails of cloud because each cloud service provider offers his own encryption. So what data is encrypted in one cloud cannot be consumed in the second cloud unless you decrypt it and send it across, right? So interoperability issues are going to be extremely challenging. cloud native capabilities therefore need start to fall. How do you manage a single pane of glass, managing all the keys across multiple key management services across the cloud? These are the solutions that that we beginning to evolve, right? And deploying consistent encryption capability with a common set of APIs, and that is where you would have your data flows, etc., that need to be mapped out very clearly to understand where your encryption solution is going to fit in, what is going to be consumed within the cloud, what is going to go into the other cloud, and where exactly you have the requirement of multiple cloud encryption and key management capabilities, right? So, and lastly, I would sort of look at the data security control model in the cloud, right? When you talk about cloud native encryption at one end of the spectrum to on-premise encryption, wherein the customer or the enterprise has total control, and the cloud native encryption where the cloud service provider has native control. You have multiple opportunities or capabilities in between. That is, cloud key, you could use cloud key management provided by the cloud service provider themselves, but then wherein key management and key lifecycle processes become shared responsibility. Then you go to your BYOK capability, bring your own key capability, wherein you are generating a key in on-prem and exporting it into the cloud. And that again, the generation is what is guaranteed is only the quality of the key and the generation that is probably being generated within an HSM that you control. But again, the responsibility of key management, key lifecycle proper, master keys, etc., is a shared responsibility with the BYOK. Unfortunately, the BYOKMS is bring your own KMS into the cloud is not a uniform capability which is available across enterprise, across the public cloud service providers. Only Google Cloud provides you your ability to bring your own KMS, and you can manage all keys that from your this thing. AWS and Azure currently do not. And lastly is, of course, obviously, you have your BYOE, that is, you take your on-prem kind of an encryption solution, offer or deploy it in the cloud with a REST API, so that applications can consume, right? So, and other end of the spectrum is on-prem. So, and what I would like to say is that from the journey from the cryptography is potentially long and arduous, but at the end of it, it's extremely beneficial and extremely satisfying if you get it right. Right, you're solving a real problem for the enterprise, and as I try to explain during this talk, it's a multi-year journey, but it needs to be very clearly planned and articulated right at the beginning. That and management of stakeholders, as well as your how you manage your transition from cloud from an on-prem to cloud becomes very important. The final thoughts for any enterprise which is contemplating on this journey is, do not get overwhelmed by the complexity of the problem. As I mentioned right at the very beginning, it's complex. Get the fundamentals right. Think big. Think, but start small. You cannot scale it up all at one go. It's not a fancy new firewall that we can do and configure within a couple of months. It's a multi-year journey. So be prepared for the long haul. But you can think big and start small. Use standards as much as possible. As I mentioned, that makes your life and interoperability so much easier. Get in a buy-in from the architects and the platform owners, because these are the folks who are going to be your biggest detractors, because it is intrusive. It is going to affect their day-to-day operations. So therefore, buy-in from architects and platform owners is very important. Articulate the risk buy down, as I mentioned, as for the layers of encryption, and what exactly is the risk buy down on each layer, and what is the risk-based decision that needs to do. Cloud-based encryption and key management is evolving. But the key thing is, if from a security perspective, you do not get your foot in the hole, even say if you foot in the door, and do not at least embrace something like as simple as a BYOK, the journey will go, you will be left behind. You will then go so deep into adoption of the cloud that is almost going to be possible for you to get back and retrofit this key control in the enterprise, right? So make sure that you are part of that cloud journey right from the very beginning if you're not already. Use native features as much as possible in the cloud. There's no harm. They're good solid products there, but factor for cloud CSP independent solutions, but because at some point of time you certainly are going to face this problem, and you will not have a chance to go back and retrofit solutions. And last thing, hiring mindset, especially for the cloud DevOps application integration space. Think from a developer's mindset, and perhaps you need to get developers into your teams. That's my recommendation, and this is largely from these are learnings that we've gone through in Standard Chartered, and as we moved from where the crypto island space to somewhere where we reasonably have an enterprise service, and we are looking to have solutions for the cloud wherein we can press and provide real benefit value, business value to the enterprise. Thank you. That's it from my side.
Thank you. Now, I request Mr. Deepak to thank Mr. Anand Kanuri.
Mr. Anand, many thanks for that insightful session. You have touched upon all aspects of practical cryptography in enterprise and cloud, including the challenges faced at your workplace, crypto as a service requirements, data security challenges in public cloud, and the scalability challenges and the multi-cloud challenges. You rightly mentioned about considering encryption as a complement to the access control. Many thanks. Once again, thanking you on behalf of members and Executive Committee of Bangalore Chapter. Thanks, Mr. Anand.
Thank you so much.
Okay.